In section 7.6, we're going to be doing numerical integration. This is an approximation technique that we used for difficult integrals before we had calculators. Now, for both the trapezoidal rule and Simpson's rule, which we'll get to in a few minutes, you do not have to have these memorized. I will be giving you these formulas for tests, so you just need to know how to use it. Also, on tests at least, I will be giving you n equals 4. I believe there's 1 or 2 homework problems where we have more subintervals, but I'll be giving you 4 just so that it doesn't take that long. Alright, so to set this up, we're going to need subintervals. So again, we're going to have 4 of them, and you'll notice we've got f(x sub 0, 1, all the way up to n. So here I'm going to have an x0, an x1, an x2, an x3, and an x4. So I need to find each of those subintervals. Now our bounds will be the first and last. So x sub 0 is going to be 0, and x sub 4 will be 2. How do I get from one to the other? Is I'm going to do this calculation out front. b minus a over n. So I subtract the bounds, and I divide by the number of subintervals. So here I get 2 over 4, which is 1/2. So to get from each of these to the other, I am going to add a half. So for x1, it's 0 plus a half, which is a half. For x2, it's going to be a half plus a half, which is 1. X sub 3, it's 1 plus a half, which is 3 halves. And just to check, x to the 4th, if I take 3 halves plus a half, I do get 2. So that does get me to where I need to be. So my trapezoidal rule, I'm going to have the 1/2 out in front. Then I'm going to have 1/2 times f of x sub 0 plus f of x sub 1 plus f of x sub 2 plus f of x sub 3 plus 1/2 f of x sub 4. According to the rule, I only multiply that 1/2 by the first and the last terms. All right, so here, so x sub 1, x of 0 is 0, x sub 1 is 1/2, x sub 2 is 1, x sub 3 is 3 halves, and x sub 4 is 2. My function here is the square root of x plus 1, so let's plug all that in. So 1/2 times the square root of 0 squared plus 1 plus the square root of 1/2 squared plus 1 plus the square root of 1 squared plus 1 plus the square root of 3 halves squared plus 1. I'm going to have to drop down a line here because I've run out of room. So plus 1/2 times the square root of 2 squared plus 1. And for that last part, I do just throw all of that into my calculator, since we do get some nasty numbers in there. And my calculator, I get out approximately 2.9578857. I'm going to leave quite a few decimal places there. So that is the trapezoidal rule. Now, we also have Simpson's rule. Now, this is going to be very similar to the trapezoidal rule. The difference here is you'll notice the coefficients, the first and last have none, and then we're going to alternate between 4 and 2. The other big difference is we've got b minus a over 3n out in front. Once again, you do not need to have this rule memorized. I will give it to you. Now our example, this is actually the exact same problem we just did with the trapezoidal rule. So now we're going to do it again with Simpson's rule, and we'll be able to compare our answers. Now the way we're going to set up our subintervals is exactly the same as we did for the previous type of problem. The one thing I want you to be careful about is the distance between each of these subintervals is always b minus a, that's an n, over n. So be careful. The first part of the Simpsons rule has a different thing in front, whereas trapezoidal rule, we had that, but this is always the distance between our subintervals. So here, again, we will get the exact same subinterval values that we had for the previous problem. All right, so we're going to do b minus a over 3n. So 2 minus 0 over 3, I'm sorry, that should say 3 times 4, yep. And then we've got f of x sub 0 plus 4 times f of x sub 1 plus 2 times f of x sub 2 plus 4 times f of x sub 3, oops, plus f of x sub 4. I hit my bracket a little too early there. So again, the first and last have no coefficients, and then in the middle it goes 4, 2, 4, 2, 4, 2. So out in front I'm going to get 2 over 12, which is 1 over 6. And then I'm going to have f of 0 plus 4 times f of 1 half plus 2 times f of 1 plus 4 times f of 3 halves plus f of 2. And again, I've got the exact same function I used last time. So 1/6 times the square root of 0 squared plus 1 plus 4 times the square root of 1 half squared plus 1 plus 2 times the square root of 1 squared plus 2. I've run out of room, so I'm going to hop down a line here. So plus 4 times the square root of 3 halves squared plus 1 plus the square root of 2 squared plus 1. And once again, I'm going to type that in my calculator to actually do the number crunching part. And so when I typed all that in my calculator, I got approximately 2.9579556. Real quick, let's briefly look back up at the trapezoidal rule. These numbers should be fairly close to one another. However, Simpson's rule is generally going to be a better approximation. Now, real quick, I went ahead and actually did this integral on my calculator. So I used the FN int, and typing that in my calculator, I got out 2.9578857. So as we look at that, the Simpson's rule is the better approximation. Basically, Simpson's rule is a refinement of the trapezoidal rule. So for our homework, you'll do this for pretty much every problem. You'll do first the trapezoidal rule, then Simpson's rule. Now, quite a few of the homework problems will ask you to actually do that integral on the calculator. If not, I will tell you to do that, because while these won't be exact, they should at least be pretty close. If you're way off, you'll definitely want to rethink your work. So that is section 7.6.